Okay, so we're cruising, people. What we want to do next, because we've set up our cache protocol and we've used it once to define an NSUserDefaults-based caching or persistence mechanism, we want to move on to the keyed archiver implementation of this persistence mechanism. So we're going to do that much the same way. We're going to create a new file. Sorry. Come on. We're going to create a new file. We're going to choose iOS source Swift file. We're going to call this keyed archiver cache. It will create a new file here, and we will, what's going on here? We will do something similar to what we did before. We'll set up a class of that same name, keyed archiver protocol, or cache, that conforms to our cache protocol and has stubbed out empty implementations of the two required methods. So let's do that. Save. So, so this is kind of our start, right? We've set up a new object, a new class, keyed archive or cache, and it conforms to cache protocol. And we've got these empty implementations here. So we want to do a couple things. We want to, in our load object for key function, we want to say nskeyed unarchiver, unarchive object with file. And we're going to pass in a path which we have yet to construct. But similar to NSUserDefaults, it's a very simple function call. There isn't a lot of work involved. And down here, when we save an object, we're also going to need a path because this is file path based. We're going to say nskeyed archiver archive root object. We're going to say that's our object to file path. Again, very, very simple. What's going on here? Well, that's not quite true. I don't know what it's talking about here. Maybe if we build, it'll go away. OK, building seems to have gotten rid of that warning. No problem. So how do we create our path? This is going to be pretty simple. I'm just going to make a new section here, a new mark section called utilities. And let's see. Let's define a private function that is, let's say, archive path, and it takes in the cache key. And it returns a string. And that will, and let's say we provide an initial return value of just an empty string. That will give us an opportunity here to say, let path equal to self.archivePath. We can pass in the key there. Same thing here. So we can ensure that we're constructing our path that we use to pass into the keyed unarchiver or keyed archiver. We're constructing that in the same way because we're getting it from the same method here, which gives us the opportunity inside of this guy to actually set up that path, define what it is. So let's do that. So let's say, actually we're going to say var path is equal to, we want to call this method NSSearchPath for directories in domains. We're going to say we want this to be the documents directory. We want this to be the user domain mask. And we want to say expand. Let's say we do this here. So what are we doing here? What's up with this? This is used. OK. Cool. So what are we doing here? We've got a private function, archive path, that takes in a key, which we have yet to use in here, and it returns a string value. The way that disk space works with respect to iOS applications, applications are sandboxed, which means that basically every application has dedicated disk space that it can use, but no other application can access that disk space. It's really just for our use. But that also means that we can't interact with the system file system. We can't modify or access other applications' file system, sort of their sandboxed file system. So we use this method here to basically get a handle or a base path to the directory called the documents directory that we can actually modify or access or write to or read from. And we do that using the ns search path for directories and domains function. And if you option click on that, you can basically see that it returns a list of paths. And we're looking for a particular path, which is the document directory. You can read more about the arguments here in this guy. But we're basically looking for the documents directory. And this is going to return a list of paths. So this is kind of shorthand for saying, give me the list of paths, and then give me the first item, i.e. the item at index 0, out of there, and forcibly convert it to an NS string. If this is not an NS string, we're screwed. Something's gone horribly wrong. And then we want to do a couple things. We want to say path equals path dot string by appending path component key, and path equals path dot string by appending path extension archive. So what's going on here? Okay, we've got something going on here. Oh, you know what? Maybe that's always right. Ah, we've got some changes for Swift 2. Okay. How do we handle this? I guess we can do that in the following way. So it's basically saying, so there's a method that used to exist on NS string, which is string by appending path component and string by appending path extension. So when I stubbed out the code for this project, it was shortly before Swift 2.0 was released. Now that we're actually recording these videos and implementing this project after the release of Swift 2, some things have changed, and this is something that I've run across before, where it's basically encouraging us to use similar methods, but on the NSURL class. So let's do that. We're going to modify this logic on the fly to basically conform to deal with these errors that Xcode is reporting to us.